Welcome to doassignment-ca. Here is the problem. A disk is driven by a motor such that the angular position of the disk is defined by theta equals 20t plus 4t squared radians, where t is in seconds. Determine the number of revolutions, the angular velocity, and the angular acceleration of the disk when t equals 90 seconds. Now, let us work through the solution step by step. The angular position is theta equals 20t plus 4t squared radians. Angular velocity is the first derivative of theta with respect to time, angular acceleration is the second derivative, and the number of revolutions is theta divided by 2 pi. We evaluate everything at t equals 90 seconds. Here is the motor-driven disk. The angular position theta equals 20t plus 4t squared radians. We need to find the angular position in revolutions, angular velocity omega, and angular acceleration alpha, all evaluated at t equals 90 seconds. Substituting t equals 90 seconds, theta equals 20 times 90 plus 4 times 90 squared, that is 1800 plus 4 times 8100, which equals 1800 plus 32,400, giving theta equals 34,200 radians. To convert radians to revolutions, divide by 2 pi, so n equals 34,200 divided by 2 pi, which equals approximately 5,443 revolutions. Taking the first derivative of theta with respect to t gives omega equals 20 plus 8t. Substituting t equals 90 seconds gives omega equals 20 plus 8 times 90, which equals 20 plus 720, so omega equals 740 radians per second. Taking the derivative of omega with respect to t gives alpha equals 8 radians per second squared. Notice that the angular acceleration is constant. It does not change with time. So alpha equals 8 radians per second squared at t equals 90 seconds, or at any time. To summarize, at t equals 90 seconds, the angular position is 34,200 radians, corresponding to approximately 5,443 revolutions. The angular velocity is 740 radians per second, and the angular acceleration is a constant 8 radians per second squared. The acceleration is constant because the position function is a second-degree polynomial in time. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.